Okay, so this is a video that we're going to do talking about composition of functions. So I'm just going to do a couple examples just to show you how it's done, both using values, numeric values, as well as finding an explicit formula through function composition. So every function composition problem starts with being given two functions. So in the first example I'm going to give you f of x equals 5x plus 3, and g of x equals 3x squared. Now remember, these functions will be different for every problem. You'll have to know what they are in order to do the problem. So what we can do is we can talk perhaps about a function composition value at a point. So we could talk about f of g of 4. So what this basically means is we're going to find the value of 4 for the function g of x, and then take that result, that output, and it's going to become the input for f. Alright, so we'll start with g of 4. So g of 4 is going to be 3 times 4 squared, and we do the 4 squared first, which is 16. So 3 times 16, that's 48. So that's g of 4. So what we do is we go back and we replace g of 4 with the number 48, and now this problem just becomes f of 48. So now we go into the f rule and we replace the x with 48. So that's going to be 5 times 48 plus 3, which is 240 plus 3, or 243. So we would say that f of g of 4 is 243. Okay? Let us try another one like this. Okay, so we'll do a new pair of functions. So we'll call f of x 2x squared plus 5, and we'll call g of x 3x plus 2. And let's change the order, let's do g of f of 2. Okay, remember, we always start with the inside function. The analogy that I always like to make is at the end of the school day, you've got to leave whatever your last classroom is before you can leave the building. So we start with the inside function first, and in this case, that's f of 2. So we'll take f of 2, and when x is 2, f of 2 is 2 times 2 squared plus 5, which is going to be 8 plus 5, which is 13. So we can go back to our main problem and replace f of 2 with 13, and now we just find g of 13, which is going to be 3 times 13 plus 2. 3 times 13 is 39. We add the 2 and we get 41. So g of f of 2 is 41. Okay? Not so bad. It's double substitution. That's the idea behind composition of functions, working from the inside out. But now let's talk about what happens when we don't want the composition of a function at a specific value, but we want to get the actual general new function that's formed by composing two smaller functions. Alright, so let's try another pair. Let's let h of x be x squared minus 2, and let's let g of x be 4x plus 1. Alright, so there's two different ways we can compose these functions. We could do g of h of x, or we could do h of g of x. And remember, as we've talked about before, this is not a commutative relationship the way multiplication is, because we're not multiplying, we're substituting one function into the other function's variable. So the order is going to matter here. So we'll start with g of h of x first. Okay, so h of x is x squared minus 2. So we just replace h of x with x squared minus 2, and now we just compute the value of g at x squared minus 2. So we'll take the x squared minus 2 and plug that whole thing into this x. So we get 4 times the quantity of x squared minus 2 plus 1, which we can simplify to be 4x squared minus 8 plus 1. And then putting the constant terms together, we get 4x squared minus 7. So that is g of h of x. Okay. Now we'll do the exact same thing, but we'll reverse the order. We'll try h of g of x. Okay, so g of x is 4x plus 1. So we'll replace g of x with 4x plus 1. So now we take this 4x plus 1, and we're going to go into h and plug it in for the x that's there. So now instead of it being x squared, it's the quantity of 4x plus 1 squared minus 2. And I constantly caution you about, whoop, I just scribbled all over it by trying to highlight it. I constantly caution you about the quantity squared when you have a binomial like 4x plus 1. Remember what that means. That means we have to take 4x plus 1 and multiply it by itself, which is a FOIL problem. So the quantity of 4x plus 1 squared is going to be 16x squared plus 8x plus 1, and then minus 2 from here. And then when we combine the constants, we get 16x squared plus 8x minus 1. Okay? So again, order matters. These are two distinct functions, g of h of x and h of g of x, which is this one right here. Okay? Let's just do one more pair and compose them generally. Alright, let's suppose we'll call f of x 3x minus 5, and we'll call g of x 2x squared minus 7x. Okay, so we'll start by doing f of g of x. So g of x is 2x squared minus 7x, so we'll replace that with g of x in our notation. So now the problem boils down to replacing 2x squared minus 7x into the x of function f. So we do 3 times the quantity, 2x squared minus 7x minus 5. To simplify, the 3 gets distributed, so we have 6x squared minus 21x minus 5, and there's no like terms, so this is f of g of x. No more to be done there. Let's go the other way. Let's do the other symbol, g of f of x. Alright, f of x is 3x minus 5, so we'll replace f of x with that. Now we're going to take the 3x minus 5, and anywhere we saw an x in function g, we're going to replace it with the entire quantity, 3x minus 5. Now this one's a little tougher because we're doing substitution in 2 spots. And again, as we talked about before, we have this quantity squared thing, so we do need to FOIL. So this is going to be 2 times the quantity, 9x squared minus 30x, and I get the 30x from doing the outer and inner of FOILing, plus 25 minus 7, 3x minus 5. Alright, so we've got to distribute the 2 into the first quantity. I get 18x squared minus 60x plus 50, and then I distribute the 7 into the other quantity, which gets me negative 21x plus 35. Be careful with that negative times negative. And then when we combine like terms, I get 18x squared minus 81x plus 85. And that is g of f of x. Okay, so this is just a couple more added examples of function composition, both at a point and as a new function abstracted to use the variable x. Okay, if you have any other questions, feel free to bring them to class. Thank you for watching.